Hey guys. All right, so let's do it. This is our homework and next class is the test, right? So it says the ratio of the length of the leg adjacent, so the ratio of the length of the leg adjacent to an acute angle to the length of the hypotenuse. Okay, so we say, what is that? Well, that looks like the cosine of an angle, doesn't it? So we're going to put the cosine. That's the name, the word all spelled out. 3. The blank gives a relationship between the sine of each angle in a triangle and the length of the sides opposite that. This one we're going to skip because this is this law of sine that we skipped. Okay. 4. The angle formed by a horizontal line and a line of sight to an object above. Okay, so a horizontal line, that comes right out of our notes. And a line of sight, and the object is above, so that has to be our elevation, angle of elevation. All right, last one. A or and blank is a set of 3 non-zeros whose numbers are satisfied by this equation. That's called the Pythagorean Triple. So those are the ones that I call famous. I nickname those famous. So a Pythagorean triple would be 3, 4, 5. I think we found another one, 9, 12, and 15 in this chapter. I think we found another one like 9, 40, and 41 maybe. That was a Pythagorean triple. Don't quote me on that last one. So that's when these are actually whole numbers. And we see these when we see these little patterns here and there when we use Pythagorean theorem, and we usually expect to get a decimal for the hypotenuse, and sometimes we don't, and that's exciting. All right, I want to go back here really quickly. I didn't answer the question for number 1, so let's go back. How are the Pythagorean theorem and trigonometry useful? So going back to our notes, it says we use them to either solve for the missing side or the missing angle in a right triangle. Nice. Okay, so let's look at a couple practice questions. It says, given this right triangle, and they've listed the sides, we know that a squared plus b squared has to be c squared because c is our hypotenuse. These are our trig ratios. So they're saying, given you have this triangle, what is the sine of d? So if d is our reference angle, this would be our opposite, and this would be our hypotenuse. So the sine of angle d is opposite over hypotenuse. So the sine of angle d is 8 over x. Notice they use Pythagorean theorem to solve for that. So another Pythagorean triple, it happens that 6 squared plus 8 squared is 36 and 81, or 8 times 8, is 64. And this gives us 100. So you say like, oh, I see what they did there. If I take the square root of 100, I get 10. So this is 10. And so instead of writing the sine of d is 8 over x, we can put 8 over 10 because we've solved for the hypotenuse. You can also see sometimes they could reduce this fraction 4/5. Nice. So let's look at a few more. It says, what would be BC? So we make x what we don't know. We'll call that x. Use the triangle to find each value. Okay. So I don't know any of the angles. I'm trying to solve for a side. So yeah, if I'm going to solve for a side, and I know 2 of the 3 sides, I'm going to call this A, this B, and this C, and we'll just use Pythagorean theorem. right? So a squared, b squared, c squared, right? And we're going to call a x, so let's start there. And then b is 5, okay? C is 8. So getting x by itself on one side. That's what we get. So BC is the square root of 39. Now, what is the cosine of B? Okay, so the cosine of B is the opposite. So I can't use A, right? They said use B as my reference angle. So if I use B as my reference angle, this is the opposite. This is my hypotenuse, and this is my adjacent side. So the cosine of B would be adjacent, square root of 39, over hypotenuse 8. So what is the value of the cosine of B? The cosine of B is this value. I'm going to just leave it just like that. What is angle A to the nearest tenth? So this is interesting because I haven't really solved for that yet, right? So now let's make our reference angle A. So then this would be opposite, and this would be the hypotenuse still, right? And that would be 8. So we could say the sine of A is opposite, square root of 39, over hypotenuse 8. Now notice I need to solve for the missing angle. So that means I should take the inverse sine to both sides. So the inverse sine, square root of 39 over 8. Okay, so the left side just turns into A, and the right side turns into this inverse sine of the square root of 39 over 8. Okay, so let's type that in our calculator. So square root of 39, and then we divide by 8. Okay, so 0.7806, 0.7806. So this is 0.7806. That's the inverse sine of that, 0.7806. Okay, so what's the inverse sine of that? I get 51.3 degrees. 51.3 degrees. And they said, leave your answer to the nearest tenth. 9. It says, Inez has a 16-foot rope to stake out the front part of her tent. So it looks like this is the tent part. Does she have enough rope? Oh, okay, so 16 would be both sides of the rope. So since this is symmetrical, we need both sides to be 8 if she has enough rope. So let's find out. Well, we have our angle, right? And that's 90. And it looks like this altitude, they're saying this altitude is 5. So let's draw this off to the side. They're saying we're trying to solve for this, right? And we have 40 and we have 5. Okay, so if we look at 40 as our reference angle, I would label this my opposite, and that's opposite the box. That's my hypotenuse. So I'm going to use the sine function. The sine of 40 is opposite over hypotenuse. So the sine of 40 is 5 over x. Using the Lynch swap, wiggling over my work here, x is equal to 5 divided by the sine of 40. Okay, so let's find out what the sine of 40 is. Okay, so the sine of 40 is 0.6427. And I want to divide that by 5. Okay. 0.6427. So 5 divided by 0.6427. Okay, so I get 7.779. Okay, so yeah, this is going to be 7. I need something a little less than 8. I need a little, so do I have enough rope? Yes. In fact, you have about 0.3 plus 0.3 extra. Okay, let's take a look at 10 and make sense. So given this triangle here, right? What additional information do I need in order to find this side xz? So let's say we call that x. What else do I need? Well, I either need side xy, this side. Ooh, that was weird. Oh, that was trippy. Okay, sorry. I either need this side, right? And then I could use Pythagorean theorem, right? Or I need angle, or if I had angle x, or if I had angle y, I could use trig. Okay, just to get that. Nice work, guys. Good luck.